The other night, I found myself in a fascinating conversation with someone who called themselves a metaphysical theorist with a love for physics. And let's call him Theo. He had a way of blending the hard science of the universe with the more abstract concepts of existence, and he was eager to talk about one of his favorite theories, the toroidal nature of the universe. The universe is a torus, Theo said, his voice brimming with excitement, a self-sustaining, donut-shaped flow of energy, matter, and even time. I laughed nervously. Okay, you've got to explain this. I thought the universe was either flat or curved, depending on who you ask. Theo leaned in. Let's start with the basics. The shape of the universe is a big question in cosmology. Scientists agree it could be flat, spherical, or hyperbolic, but what if it's toroidal, a donut shape where space-time curves back on itself? This isn't just metaphysics, it's mathematically possible. Theo explained that toroidal models have a basis in physics. You know how magnetic fields often take on a toroidal shape, like the ones in tokamak reactors or the Earth's magnetic field? The torus is incredibly efficient. It balances energy flow perfectly. What if the universe itself is operating on these same principles? He brought up Einstein's theory of general relativity, which describes how space-time can curve. If space-time can curve, why not wrap it into a torus? In this model, if you traveled far enough in one direction, you'd end up where you started. It's like a cosmic video game map with no edges. Okay, that's wild, I said. Wait, but how would that work with, say, the Big Bang? Theo grinned. The Big Bang could be the point where energy spiraled into the torus, creating the continuous flow we see as expansion. As energy circulates, it sustains the universe, and when the flow slows down, it could contract, leading to a big crunch or another Big Bang. A toroidal universe aligns perfectly with cyclical models of cosmology. Theo shifted gears into quantum physics. Have you heard of torsion fields? He asked. I shook my head. Torsion fields are theoretical energy fields created by spinning objects. In a toroidal universe, the spin and rotation of cosmic structures, like galaxies, could create torsion fields that sustain the torus's energy flow. It's like the universe is constantly spinning itself into existence. He also tied it to quantum entanglement. If everything is connected in a torus, quantum entanglement makes even more sense. The toroidal structure could facilitate instant communication between particles, no matter the distance. Theo's favorite part was the implications for time. Think about time as a loop, he said. In a toroidal universe, time might not be linear. Instead, it could spiral, with the past, present, and future all interconnected. This could explain phenomena like déjà vu, or even the idea of destiny. He pointed to the arrow of time, which physicists often describe as moving forward due to entropy. But in a toroidal model, time's direction might depend on where you are in the torus. Some areas could experience time differently, creating zones of accelerated or slowed time flow. Theo couldn't resist diving into the metaphysical side. A toroidal universe suggests that everything is connected. Energy flows through the torus, linking all points. This could be the scientific basis for concepts like universal consciousness, or the idea that what goes around comes around. He also speculated on creation. If the universe is toroidal, it's self-sustaining. There's no need for an external creator because the system creates itself. But if you believe in a higher power, a toroidal universe could be the ultimate design, a structure that balances itself perfectly. I raised a skeptical eyebrow. But wouldn't we have noticed if the universe is a torus? Theo nodded. Fair point, but we might not be looking for the right signs. Astronomers have found hints that the universe might wrap around itself, like patterns in the cosmic microwave background. Plus, our perception is limited. If the torus is large enough, we might mistake it for infinite flatness. He admitted there were challenges. The model needs more evidence, and it has to align with observations like dark energy and cosmic expansion, but it's a compelling framework that bridges gaps in our understanding. Theo wrapped up with some thoughts on what this means for our future. If the universe is toroidal, we might one day tap into its energy flow. Imagine harnessing the torus's structure to travel vast distances, or even between dimensions. It could also help us understand our place in the cosmos, not just as observers, but as participants in this infinite loop. As the conversation ended, I felt both enlightened and unsettled. Whether or not the universe is a torus, the idea offered a new way to think about existence, one that's as scientific as it is poetic.